Hello viewers, welcome to my YouTube channel Mathematics Made Easy. Alright, so in today's video we'll be doing more on our topic, which is indefinite integral. So from our previous videos we've talked about a lot of concepts, and then we've solved a lot of examples. So in today's video we are looking to this new concept. Okay, so if you are new to this channel, please don't forget to subscribe, like, comment, and also share. Yeah, so thanks for doing that. All right, so let's dive into work. So whenever you have this kind of function that you want to integrate, so when the denominator when the derivative of the denominator is what in the numerator, all right, the resulting answer will be natural log of f of x plus c. I forgot to put the constant, right, plus c. So before we do examples on this concept, so I would like to derive this particular expression. Okay, so how do we derive this? Now here's the first thing we're gonna do. So we're gonna make use of substitution, right? Then we'll say let me be using u for the substitution. So I can say let u be equal to this, my f of x in the denominator. All right, then we're gonna differentiate with respect to x and u. So by differentiate u, I'm gonna have the u. Then if you differentiate f of x, I'm gonna have f prime of x dx. All right, so definitely we have f prime of x dx here. So that shows that f prime of x dx is my du. All right, so then I can rewrite that integral as follows. So I'm gonna have integral of, so instead of me writing f prime of x dx, I will write the u. Then instead of me writing f of x, I'll write u. All right, then don't forget, if you integrate this kind of function, you have 1 over u, 1 over x, any letter. So we are integrating it, so this will surely give us natural log of u, then plus the constant c. But remember that u is f of x. All right, then substitute back u. So we do that, we're going to have natural log of f of x, then plus c. All right, so that's how you prove that. Okay, now let's do some examples related to this expression. All right, example 1, I'm gonna do 3 examples. Okay, so example 1, so let's say we have integral of 1 over x plus 1 dx. Okay, so then if you check this kind of integral very well, you can see the derivative of this x plus 1 is what in the numerator. Are we together? So we can see that we can write these integrals. So instead of me writing 1, I can write the dx of x plus 1 then over x plus 1 dx. Why? Because if I differentiate x plus 1, I'm going to have 1. Okay, so then surely if we apply this particular rule, this will give us natural log of x plus 1. That is, our f of x is x plus 1, then everything plus c. But if you don't want to do it this way, you can do it another way around. All right, that's like by making a substitution. Okay, so alternatively, so we can say that let me use another marker. So we can say that let this your denominator, which is x plus 1, be equal to u. All right, then you differentiate. If you differentiate x plus 1 with respect to x, you have the x, the x. Then if we differentiate u with respect to u, we have the u. All right, so definitely you can write the x as the u, then you write x plus 1 as u. So you're gonna have integral of 1 over u, then the u. So if you integrate 1 over u du, that will surely give us natural log of u plus c. And remember, u is x plus 1, so this will surely give you natural log of x plus 1 then plus c. So that is the answer. Are we together? All right, let's do another example. Okay, so example 2, we have integral of 2x over x raised to the power of 2 then plus 4 dx. So how do we integrate this particular function right here? All right, now if you check the denominator and the numerator, we can see that the derivative of the denominator is 2x. That is, if you differentiate x squared plus 4, we have 2x. Okay, So we can now write these integrals, integral of d dx of, instead of me writing 2x, I'm going to write s squared plus 4 then over s squared plus 4 dx. Okay, since we know that if we differentiate s squared plus 4, that is 2x, that's why I write this way. So definitely this will give us natural log of s squared plus 4 then plus the constant c. If you don't want to solve it this way, you can use this second method I taught you guys. All right, so that will be the answer. And then the last example for today, and here's the question number 3. We have integral of 2x over x raised to the power of 3, okay, plus 2 dx. So squared is here. Yeah, let's put square there, so to not make the question complicated, you understand. All right, so let's solve it this way. So how do we now integrate this? I think this is somewhat different from what we have been doing, but we can also solve this using the same method. Okay, so let's do this. Let's move to a new page. All right, let's move on. So we make a substitution. We say let u be equal to x cubed plus 2. All right, let u be equal to x cubed plus 2. Then if we differentiate, we're going to have the u equals 3x squared. So what do we notice here is that if you look at the numerator, we have 2x squared, but if we differentiate the denominator, we have 3x squared. You don't have problem. All right, we can actually fix this. So let's just move on. So we're going to write these as integral of 2x squared then over, so this is now u, don't forget, then this is forgot to put the x, then you make the x the subject of the formula. So if we do that, you're going to have dx equal to 1 over 3s squared du. So instead of us writing the x, we're going to write 1 over 3x squared du. So we have multiplied by 1 over 3s squared du. All right, so we can see x squared will surely cancel s squared. You can see that's very beautiful. So I can bring out 2 over 3, so I'm going to have 2 over 3, then integral of 1 over u du. So this will give us 2 over 3 natural log of u plus c. Then you substitute back the original function of u, which is x cubed plus 2. So definitely we have 2 over 3 natural log of x cubed plus 2, then everything plus c. So that's the answer to that beautiful problem. All right guys, so that will be the end of today's class. So like this kind of video, please don't forget to subscribe, like, comment, and also share. Thanks for watching. See you next time. Bye.